Hey, and welcome to the isoPoint training series. I'm Eric with Aktina, and today I'll show you how to perform an Isocenter validation with your isoPoint. Isocenter validation is a Winston-Lutz test that is used to measure your LINAC's geometric errors. Unlike a traditional Winston-Lutz test, you won't be using this test to figure out how to troubleshoot errors if they come up. Thankfully, we have other isoPoint workflows for that. With isoPoint, the Winston-Lutz test is used as a final step to confirm your LINAC's Isocenter is optimized. Before we dive in, let's quickly go over the main Isocenter validation steps. First, you'll measure an iMark dataset to determine the physical Isocenter. Next, you'll position the isoPoint target module at the identified physical Isocenter. After that, you'll acquire radiation images using your EPID with the target precisely at the physical Isocenter. Finally, you'll import the EPID images into isoPoint and review the results. For this video, we'll assume you've already measured your iMark and positioned the target at the physical Isocenter. But before we dive in, there's one more thing we need to cover: a quick overview of the imaging templates. Imaging templates let you define the images that will be acquired in your isoPoint Winston-Lutz test. This includes an ordered set of gantry couch and collimator angles. Before analyzing images, you'll need to create at least one Isocenter validation template. To do this, go to the Templates tab and create a new Isocenter validation template. You only need to do this once, as the template will be saved in the software for future use. To create a new template, click the plus button and a new template will appear in the table. Then enter the angles for your Winston-Lutz test using comma-separated values. In this example, we're using the 4 cardinal gantry angles and 5 couch angles. Pro tip: for a full validation, make sure to include the cardinal gantry angles and a couch 0 rotation. There are also checkbox options if you want to run a gantry only or couch only test. Once your template is set up, we're ready to jump into the isoPoint Winston-Lutz test. In your session, create an Isocenter validation dataset by clicking the Create Isocenter Validation Dataset button. A dialog box will pop up, prompting you to select the template you just created. Next, choose the energy. Here we'll go with 6 MV, but you can adjust the photon energies in the general settings if needed. The dialog will also ask if you're using a flattening filter-free beam and prompt you to select 2 different collimator angles for each gantry angle specified in the template. At the bottom of the dialog, you'll find options for target placement, couch axis, and collimator axis. The target placement setting lets you specify where your target was placed, while the other 2 options allow you to include couch and collimator optical tracking data in your Isocenter validation report. We highly recommend including this data. It really helps with interpreting the results. You'll now see the measurement items. In this case, 13 EPID images for the 4 cardinal gantry angles, along with the 5 couch rotations. Notice that the collimator angles for each gantry measurement are also displayed. The dataset will also include beam axes and marker shift items, a radiation isocenter item, and an Isocenter validation report. These will all be computed once the images are imported and processed. With your isoPoint target positioned exactly at the physical Isocenter, acquire EPID images in the exact order shown in the session tree. Be sure to use a 4 cm square field, as isoPoint expects a specified field size. Each tree item label describes the expected gantry, couch, and collimator angles for each measurement. Note that isoPoint uses collimator pair images for each gantry angle, and each pair must include a 180-degree collimator rotation between them. Once you've acquired all the EPID images, export them from the LINAC and import them into the Isocenter validation dataset. Keep in mind that isoPoint accepts both DICOM and TIFF formats. To import, just select the dataset, click the Image Import button, navigate to where your images are saved, and select the folder. Or even easier, just drag and drop all the images right into the dataset. Once imported, the software will process the images and compute the radiation Isocenter and Isocenter validation report. For more info about the Isocenter validation report, check out the Isocenter validation report video linked below. isoPoint also shows the results in the 2D and 3D windows. In the graphical view, you'll see the data displayed in the same coordinate system as your optical tracking data, with beam axes shown as red vectors and couch-induced marker shifts as purple 3D points. Pro tip: We acquire collimator opposed images for each gantry angle to determine the radiation beam axis at that angle. This helps separate MLC calibration from the Winston-Lutz test, so any MLC issues don't interfere with the test, which is mainly meant to measure geometric errors. But don't worry, if you're used to seeing field versus marker errors, the last page of the report has that data for you. Lastly, if you want to view the processed image results, double-click on any of the imported images to open the image processing results window. If you have any questions about the Isocenter validation workflow, reach out to our support team at isoPoint@aktina.com. Thanks for watching, enjoy using isoPoint, and see you in the next video.